Australian livestock industries produce significant amounts of waste products in the form of liquid effluents, solid manures, and compost. What have long been considered waste have the potential to transform into valuable fertilisers and soil conditioners, offering a wide range of benefits across agricultural sectors. These wastes can supply essential nutrients, beneficial microbes, and enhance soil carbon, resulting in improved soil condition, better water retention, and increased resilience to drought and climate variability. But that's not all. These materials could even offset our reliance on synthetic fertilisers and generate biogas for renewable energy. However, this opportunity doesn't come without its barriers. The unbalanced nature of the nutrients, along with the sheer volume and management of these materials, presents a significant challenge. Transporting, managing and reusing this resource is estimated to cost Australian farmers $100 to $200 million annually. The Smart Farms program, funded by the Australian Government's National Landcare program, in partnership with our research partners, has undertaken research to overcome these challenges by identifying ways to manage and maximise the benefits of waste products whilst minimising environmental impacts. It aimed to do this by demonstrating improved water quality and availability, optimisation of biogas for energy production, identification of regulatory barriers, and developing enhanced fertiliser formulations and soil improvers from manure products. To achieve these aims, a collaborative research team utilised advanced and rare research technology, such as extracting and sequencing beneficial microbes and using cutting-edge solid separation technologies. They're also quantifying emissions, optimising biogas production, and even employing robotic growth accelerators and 3D scanning to understand nutrient supply. The program has demonstrated results never before seen in Australia and have generated data to help better understand the processes involved in livestock manure-derived products. Some of the exciting results from the program include: using coagulants and flocculants, researchers achieved for some nutrients up to 95% retention in the solid fraction, ready for use as a fertiliser. This process also dramatically reduces turbidity, providing farmers with clearer liquid for various purposes such as washdown. New solid products derived from coagulants like acacia bark have shown promising results, performing as well as raw effluent in pasture response. The team discovered that covering manures with materials like compostable plastics can immediately halt ammonia emissions, making the manure a more valuable and sustainable nutrient source, which allows farmers to reduce synthetic fertiliser use. The program has shown waste-derived fertiliser are not second-class products. In fact, they can rival or even outperform conventional fertilisers. The research found that by adjusting the carbon to nitrogen ratio and incorporating nitrogen inhibitors, they've achieved higher efficiency and nitrogen uptake from waste materials. This not only reduces leaching and gaseous losses, but also creates a value-added product that can defeat conventional fertilisers. Better understanding the processes allowed the development of advanced fertiliser products derived from the different activities within the program. Biogas is a 24/7 renewable energy source that can be produced from manure. Researchers found that dairy digesters are more resilient than previously thought, capable of handling higher loads. This means smaller, more economical systems could be viable. Interestingly, cows on pasture show lower methane potential than those on grain in intensive housing systems, allowing farmers to tailor their strategies for either maximising energy recovery or minimising greenhouse gas emissions depending on their system. The information derived from the biogas research has also provided scientifically rigorous data never collected before in Australia, which can be used to forecast biogas benefits, be used in greenhouse gas accounting, and be used to develop economic feasibilities. In Western Australia, an exciting discovery was made. The team found the addition of a stabilised compost to soils encouraged the growth of iron-dependent methanotrophs, which was associated with a higher consumption of methane. That is, the microbes that consume methane rather than emit it. This finding opens up new possibilities for reducing methane production through targeted soil amendments. This team also developed modified higher quality granulated products with multiple benefits compared to raw manures and compost, being easier to transport and apply, odourless, less leaching and greenhouse gas emissions, as well as an increased crop yield equivalent to that of synthetic fertilisers. Research from the program found that traditional composting methods for layer manure can be costly and can result in up to 50% ammonia loss. However, this program found by simply shortening the composting period, we can reduce both ammonia emissions and processing costs. But there's also another innovation, large-scale manure drying, a technology that has not yet been seen in Australia on a commercial basis. This method can cut ammonia losses by 60 to 80% compared to composting and stockpiling. Moreover, dried manure is proving superior to raw and composted layer manures in plant production. Results show that it provides better nitrogen supply and efficiency, which can help farmers reduce their reliance on synthetic fertilisers. Along with the practicalities of waste management, other challenges remain for the use of livestock-derived products. The program found that inconsistent regulations, waste classifications, and like industry requirements across Australia creates a maze of barriers for farmers and innovators alike. The research also highlighted opportunities for regulatory reform, including revising waste classifications, implementing risk-appropriate conditions, and fostering collaboration between industry and regulators to allow greater adoption and use of the products. This Smart Farms Pilot to Paddock program has demonstrated that through innovative water, energy and nutrient technologies, we're not just managing waste, we're creating a resource that could transform our agricultural landscape. For those wanting to learn more, the Smart Farms video series offers a more detailed overview of each of the activities that make up the Smart Farms Pilot to Paddock program.